In this video, we begin our introduction to instruction set architecture design, and we're going to look at the encodings of Intel x86 platform, which is a 32-bit set of instructions. So this is the set of topics here, and we have a few handouts. Let's take a look at the first handout, and I will open just the handout format here. So when we start talking about instruction format design, we're going to analyze the set of operation codes of individual instructions on x86 platform. And this handout presents a set of ideas that corresponds to considerations that typically are taken into the instruction format design, basically how the opcodes should be configured. And one of the approaches is that when these bit fields of individual bytes that represent instruction opcodes are decoded inside the processor, the circuitry becomes simpler if we subdivide the byte codes that represent individual instructions into bit fields. So basically we say that, for instance, these 3 bits could be indicating the actual code of an instruction. This could be the code of a register, and this could be the memory addressing mode if this instruction wants to work with memory. So these are individual bits in an example of one single byte with 8 bits. And so the idea is to break encodings into individual bit fields. Now, in this handout, we present a set of ideas that correspond to constraints and limitation of the number of 1 byte or 8-bit encodings, and then 2-byte size instructions, and even larger. So essentially, the idea is that, of course, we want to keep our instructions as small as possible. So again, just read this handout. It's a general set of ideas that introduce concepts such as complex instruction set computer and reduced instruction set computer. Just read this information, and on Intel we're going to deal with variable length opcodes. So the opcodes will be different. So just an example of a 1-byte opcode, we may decide that a specific set of instructions may be encoded with 0, 1, 1, 0, and 1, 1, and reserve 0, 0 for future expansion. So then we basically can have these bits to represent individual details about the instruction. With the 2-byte opcodes, we can designate that 2 zeros in front of the instruction with the 1 bit over here in this position could be extended with opcodes that are constructed out of these 5 bits and 8 bits of an additional byte of this instruction. So as part of the same family of instructions here, we have 1-byte size instructions with just 2 bit fields reserved to designate different categories of instructions. And here 0, 0, which is not present in the set of these encodings, allows us to jump over and say this instruction will actually use an additional byte to encode the whole range of instructions. And the ranges of instructions here, if for instance, if we have 6 bits dedicated to unique patterns of instruction encodings, of course this be 2 raised to the 6th power, it gives you 64 unique instructions, which will have overall 1 byte size. And at the same time, if we have these 5 and 8 bits, which altogether is 13 bits in these 2 bytes, we can decode as many as 8,192 instructions. So this is an idea of instruction expansion, because we probably may not necessarily initially, when we design our instructions, we may not initially allocate all of these 8,000 instructions, but at some point we may start running out of opcodes that we want to be adding to our system. And then if we change the to 0, 0, so if we have 3 bits set to 0, changing this bit to 0, we can then expand into a 3-byte size instruction. So then these X bits that are marked with X's become 21 unique bit fields. So this will give us approximately 2 million different instructions. So this is how opcodes can be organized on a complex instruction set machine, which supports variable sizes of instructions. On a reduced instruction set machine, the instruction sizes are uniform. So basically they're just typically on a 32-bit platform, they'll be 32-bit sized, and on 64-bit platform, the instruction is 64-bit in size, each instruction. All right, so these are interesting ideas, so I encourage you to read through this handout. Okay, so this handout right here is just the ideas regarding design of an instruction set that could be possible utilizing all of these generic ideas with bit fields that we just discussed. Our next handout is going to be encoding real instructions of the Intel x86 platform, the 32-bit size instructions. And so this is our presentation for this section of our course. And this is a general look at the Intel instruction on its 32-bit platform.